Not going to go into a lot of the technical details of the sensors themselves. Talking with Jerry, who's also on the call today, we looked at how we're using some of this technology. So Sanborn's been flying the Ultracam Osprey system since the first generation was released. We're now on the Mark III Osprey and done a number of projects with it. It's been a very reliable system. And as we look to the future, Vexcel has recently released their Osprey Mark 4.1. I'm not going to go into the differences and all the things that make the 4.1 different from the Model 3. There's a couple of those summarized here. Mainly it has to do with the capture rate and the resolution and capability of the cameras in the system. And if anybody wants to get into the details of all that, I encourage them to get hold of Jerry, and he can walk you through everything that makes that new 4.1 a really nice system. What we've been focused on is using oblique data for our customers, primarily in two modes. One is the traditional oblique imaging that many of the tax assessors and other asset managers use. And the second is in the 3D world. What makes it unique from a non-metric camera system is the ability to do the aerial triangulation for all views of the system. That gives the capability to do measurements that are very accurate. And when we go into the world of the tax assessor, they need that accuracy. So what does that mean? Well, it means in an oblique image, when you drop a point and you have the elevation data, you now, as you rotate around through the images, you don't move. That point stays fixed. So at any angle you now look at that building, you're in the same exact spot as you rotate through the oblique images. You can now measure accurately height, lengths, and areas. And when you're looking at the world of assessment, being able to do this accurately means a lot, because I don't know if many of the states you guys operate in have recently encountered this, but here in Colorado, as a result of tax reassessment, we've got a significant number of lawsuits going on where the owners of the property have taken on the tax assessors in court, and they're trying to get changes made to the assessment. So this fundamental accuracy becomes a big deal. Measuring, roof slopes to get true areas on non-flat items. So it just goes on and on and on the uses of the oblique data that's been processed accurately, and that's the key. But the new buzzword in the marketplace is digital twins. And so I'm going to do a short video to put us all on the same page with what is a digital twin. So what's new in the Ultramap software that works with the Osprey is the ability to edit the DSM. Previously, you got what you got when you ran the software. Now you can go in, you can edit the DSM, you can edit the textures, you can remove or edit objects. So this gives you the ability to do a lot of manipulation to the data that can then be used to create a 3D model or a digital twin. You can edit actually the tin that underlies these mesh digital twins. So just to give you an example of one, you're looking at the underlying network that created the mesh network and some of the buildings. And if I turn off the wireframe and turn on the textures, you see the underlying 3D. And so up until pretty recently, what the customers got to do with this is look at it, which for many customers was good enough. You know, they could zoom in, zoom out, move around. Understand the environment, maybe do some simple analysis, but there wasn't a whole lot of interaction they can have. So moving back to the presentation. What changed was the ability to bring it in to a GIS. So now all of a sudden in ArcPro, you can bring your digital twin in with traditional GIS data. So here's an example of parcels. Another example of street center lines. And kind of moving through the data so that you can see it as it works in ArcPro now. From a visualization standpoint, we turn on the parcels. And this was data processed from the Osprey. And then we just downloaded Denver's public data into ARC to see how everything worked and how it lined up, and it working with the GIS manager in Denver, they were amazed at the capabilities. This one is the tree inventory. And they actually, once they saw we could do this, they actually went out and did a validation of all the points against the 3D data so they could see if they had captured all the trees. So what's occurred now is that there's a very big use for these digital twins in our traditional GIS marketplace. And we're seeing demand occur out in the market. We've already got 2 customers who want digital twins of their areas, and they're planning to use Esri's Arc Pro to host it, and they're moving to a 3D GIS. So with that, if anybody has any questions, feel free to ask, or when you start talking about the capability of the Osprey, Jerry's on the line, and I would reach out and contact him.
This is Jerry Scow, I just want to quickly say thanks to John for doing this today. When we decided to sponsor this virtual event, what we wanted to do was we wanted to talk about our technology and application, not necessarily boast, do the chest beating about the products and features of the product itself. So John, thanks so much for sharing what you've been doing with both our hardware and our software.
All right.
John, there is one question there.
Okay.
What projection is the 3D digital twin using?
What projection?
Yes.
I believe it's the underlying datum is WGS84. I don't get into the actual production of the data, so that'd be a question for one of our operations folks.
Okay, I have a question about how a municipality or local government, federal government, whoever would use that data from a cost standpoint. Is there any real difference in cost for the GIS, on the GIS side, on the acquisition side, production side, for them to move their traditional 2D mapping into the 3D mapping that you're showing?
So if they've already moved to high resolution oblique data, the cost difference is pretty minimal. And compared to how we used to do this, we started, building 3D models, large areas. We did 150 cities of 3D models right after 9/11 for insurance companies, and then DHS bought them, and a number of other people did. And they were all manually compiled buildings, very expensive. As the technology moved, we saw the cost continue to go, come down more and more and more. In 2005, we did the city of Dubai for the Dubai police, and the mesh technology just wasn't there yet. It was starting, but wasn't capable at that point. And again, we compiled buildings and compiled, street furniture and everything else. As we got into 2010, 11, 12, mesh got better. We saw the Ultramap products start to have that capability. We saw Bentley's products start to have that capability. The Hexagon products started bringing in that capability as they got into oblique imaging. And it's just continued to improve the resolution of the sensor, the area coverage of the sensor. I mean, you know, we used to have, what, 25 megapixel, you know, Canon cameras for oblique systems. And as the improvements in the cameras happened, now all of a sudden we're able to cover a pretty large swath with a, you know, 7.5 centimeter resolution. And so the cost comes down. So, you know, yes, it's more than a 6-inch ortho, but compared to an oblique job, it's not that much more. It just takes more processing. The key is getting with your customer and agreeing on the spec for the 3D data. You know, it doesn't matter if it's just imagery or if it's imagery with LiDAR, you're going to have some warps, you're going to have some edits, some things that don't look quite right. And you've got to, you know, you've got to get agreement up front on what that quality spec is going to be, because everything will not be perfect, but it's a way better product than it used to be.
All right, John, thank you very much. Appreciate your and Sanborn support. Jerry Skull, thank you to you and Vexcel as well for sponsoring this session.